Hello, Math 130 students, and welcome to the very first day of lecture. So today we are going to go over Chapter 1 notes. So we're going to go ahead and start on page 1. So Section 1, linear equations in one variable. And I'm just going to go through this tutorial, and you guys, if you have any questions, please feel free to email me. So we're going to start with some vocabulary. An equation is a statement that indicates that two quantities are equal. An equation has an equal sign. So you can always just think about this as the definition is whenever you see the word equation, then you can think of having the equal sign, okay? So you know that this is an equation because you see the equal sign there. So 2x squared plus 4 equals 6. So equation has the equal sign. Now, for the definition for a linear equation in one variable is often called a first-degree equation because the variable x has an implied exponent of 1. So here we are talking about if we were to have 3x plus 1 is equal to, let's say, 4, then we say that this is going to be first degree because even though you don't see it, and you don't have it written down, we can assume that the exponent is going to be 1. So therefore, we're going to say that this is a first degree equation. All right, so for example, or another definition, it says a linear equation in one variable is an equation that can be written in the form ax plus b is equal to c. So 5x minus 1 is equal to 9. So that's kind of giving it to you in sort of a y equals mx plus b form. So let's dig into this a little bit more. So we have an example. It says determine if a value is the solution to an equation. So we want to know if when we plug in that variable, whenever we see that c is equal to a negative 1/2, that we are going to plug it in to the c variable. So we're going to plug in c value whenever we see that c. So we are going to write this down. So I'm going to say that this is 7, and my c value is a negative 1/2 plus 5 is equal to negative 7, and my c value is a negative 1/2, and I have a minus 2. So here, I'm going to plug this into my calculator, and I want to know whether or not this is going to be true. So we are determining whether or not this is going to be equals. So when I think of the word determine, the answer, you want it in a yes or no form. Did it work or did it not? Did it not? Was it a value of the solution? So let's see if it's equal to each side. So you can bring up your calculator if you have it. I'm going to go ahead and bring up mine. So now I brought up the calculator, and remember this is the same calculator that you can download from the home page, and it's free. You can download this for free right now if you go to that link. It's free for students throughout the COVID-19. Just something that you can download onto your computer if you guys want to bring this up on your own. So let's go ahead and figure out if these two sides are going to be equal to each other. So I'm going to plug in values on my calculator. So 7 times, and for a fraction, you can always go ahead and put it inside parentheses and say it's a negative 1/2. And yes, sometimes there's a faster way to put it into fraction form, and that's fine too. I'm just trying to do it so if you did not have a graphing calculator, you can still do it on a non-graphing calculator, okay? And so plus 5, and that is going to equal to a 1.5. So I'm going to go ahead and write down that value. So this side was equal to a 1.5. And we will still want to see if that opposite side, the right-hand side, was also going to be equal to the same value. So let's go ahead and plug that in. So I have negative 7, and it's a parentheses, a negative 1/2 minus 2. And so I get that this is going to be, touch screen, negative 5.5. So I'm going to go ahead and plug that in. So notice how 1.5 and negative 5.5 are not the same value. So therefore, these are going to be not equal to each other. Was it negative or was it positive? It was negative. Okay. So so negative 5.5. So we know that these are not equal to each other. So whenever these are not going to be equal to each other, you're going to say that there's no solution, or not a solution. Okay, so you're going to say no, not a value of the equation. Or better yet, not a solution. So we're going to say no, not a solution of the equation. So that value c is equal to negative 1/2, when you plug it in, it means that both the sides won't equal to each other. So now we want to go into the second example. It says, which of the given values is a solution to the equation? So here we want to know whether or not, if we plug 1 in, or negative 11/2, or 9, or negative 1 into the equation, whether or not that's going to be a solution. Is it going to be equal, or is it not going to be equal? Well, we already saw what's not going to be equal, meaning that it's not a solution, so both sides are not the same. So let's go ahead and start plugging in these values. So for part A, what we are saying is that D is equal to a positive 1, since that value for part A is 1. So we are going to plug it into this equation. So we have negative 3, and that D value is 1, minus 4 is equal to 9, and that D value is 1, and you have plus 7. So I'm going to go ahead and bring up that calculator again. So it's a negative 3 times 1 minus 4. And we're going to get that that's negative 7. So I'm going to go ahead and plug it in for the other one. So 9 times 1 plus 7. So that's a 16. So I have one side equal to negative 7 and the other side equal to 16. So are these values equal to each other? No. So A is not a possible solution. So now we're going to go into value B. So we know that the D value is equal to negative 11/12. So I know that I'm going to be plugging it into this equation. So here, instead of the blue, I'm going to have green. And I'm still plugging it into the equation as negative 3 minus 4 is equal to 9 plus 7. So notice here that I'm putting parentheses around the D value that you're plugging in. So that way you can think, okay, no matter what the D value is, this is what I'm going to be dumping the equation into. So for now, we are going to be dumping this into my parentheses. So when I plug this into the calculator, let's go ahead and move things around here. There we go. So now we're going to have a negative 3. Oops, one too many negatives. Negative 3 times my negative 1/2, or 11/12, minus 4. So now that I've made sure that I've entered it correctly, now I'm just going to press enter and see what that value is going to be. So I know that the left-hand side is going to be a negative 1.25. So now I'm going to plug it into my right-hand side. So I'm going to have 9 times my negative, oops, your negative 11/12, and then you have your plus 7. So now I'm plugging into the right-hand side of the equation. So now when I press enter, I see it's negative 1.25. So notice how the left hand and the right hand are equal to each other, so we know that these are going to be equal values. So now that I know that these are going to be equal to each other, then I know that B is going to be a solution to the equation. So the general strategy, the goal to simplify the equation is to isolate the variable. So let's always what we're trying to go for. So maybe you're going to add, maybe you're going to subtract, maybe sometimes you're going to multiply, sometimes you're going to divide, right? You're going to do all these different operations depending on the equation that's given to you. But your main goal really is to try to isolate it the best you can. So make sure it's all alone, kind of like on a deserted island, okay? So here we have the properties of equality. So we have addition. That means if you add to one side by the same amount on the other side, they're going to be equal. So here you are increasing by the same value. So you added C and you added C. And then same thing happens if you subtract C on both sides. You're adding and subtracting the same amount on both sides. So of course they're going to be equal to each other, right? So for multiplication, it's the same process. So if you multiply by the same value, they're going to be equal. And if you divide by the same value, it's also going to be equal. So let's go ahead and keep these rules in mind. And that's going to kind of guide us on isolating the variable. So for the first example, number 1, we have x plus 6 is equal to 28. So what we're going to do, since that is addition, the opposite of addition is subtraction. So minus 6, minus 6. So now you're going to enter 28 minus 6, and that's going to be 22. So now you know that my value is x is equal to 22. Now for number 2, what's happening is now you have 12 minus x. So now you have a subtraction. So what's the opposite of subtraction? Then we would do addition. So using the addition property of equality, we're adding by the same amount on both sides. So what I can do is I can, let's see, if my goal is to isolate x. So I want to get x all by itself. So I don't know, I can keep it on that side and I can, subtract 12, or I can add x to both sides. It really is up to the student on what they want to make, what choice they want to make. So I don't know, I'm going to subtract 12. So when I subtract by 12, I'm going to have that negative x is equal to, and now I have 40 minus 12, which is a 28. So if I divide by a negative on both sides, then I'm going to have that x is equal to a negative 28. So my answer is x is equal to a negative 28. Now for number 3, using these rules, I'm going to rewrite this just because I have a little bit more room. I don't want to get sloppy with this because it's a fraction. I have 8 is equal to a w over 2.2. So my goal is to isolate that w. What's happening is it's being divided by a 2.2. So to do the opposite, you would multiply by 2.2. And if it makes it easier for yourself, you can put a 1 underneath it, so that way you can think of it as a fraction times a fraction. So then over on this side, you're going to multiply by 2.2 as well. And if you want, you can think about it as a 2.2 over 1. But it's the same as saying 2.2 since the denominator is 1. And you're not multiplying by a fraction, so I really just would keep it as a 2.2 that you're multiplying by. So now if you have a 2.2 times 8, then you're going to get a 17.6. And then what happens on this side is that since you have a 2.2 in the numerator and the denominator, they cancel out and you're left with w. And it doesn't really matter now that w is isolated. You can keep it on the right-hand side, or you can move it over to the left-hand side. So I'm going to go ahead and just move it to the left-hand side. So I have that w is equal to a 17.6. So the same sort of thing is going to happen with number 4. I'm just going to go ahead and rewrite it to give myself more room. So I have a negative 4/5 x is equal to 20. So that means since I want to get the x isolated by itself, then I need to multiply and get rid of that fraction. They might be thinking, wait, it's multiplication between it. Well, to get rid of a fraction, you can always multiply it by its reciprocal. So the reciprocal just really means, you flip the numerator and the denominator. So if I multiply by the same amount on the same side, we're actually using the property of equality for multiplication, okay? Because what we're doing is we're multiplying both sides for the same side. So now what happens is that now that these are reciprocals being multiplied together, they cancel each other out. So now you have that x is equal to 20 over 1 if you want, over your 5 over your negative 4. So you can either use your calculator, or you can think that 20 and negative 4, they can both be divided by 4. So 20 divided by 4 is 5, and negative 4 divided by 4 is a negative 1. So you're left with 25 over negative 1. So x can be written as x is equal to negative 25. So then x is equal to negative 25 is going to be my answer. For number 5, I'm looking at that and I'm like, okay, my goal is to get the w by itself. So you are going to add by 6 on both sides. So that 4w is equal to, and 22 plus 6 is equal to 28. And 28 divided by 4 is going to give you 7. So you have that w is equal to a positive 7 as your final answer. For number 6, you can see that now we're adding parentheses. So now we're going to be using the order of operations, but it's still the same type of method. So I have 7 plus, and I take this 2 and distribute since it's being multiplied. And I have a 2y minus 6 is equal to a 6y plus 3. So now that I have a 2y and 7 minus 6, I'm going to have a positive 1. And now on the right hand side, I'm just going to copy that down, so 6y is plus 3. So now what I want to do is to get the y by itself. So since y is here and here, you just make a choice. Do you want your y on the right hand side, or do you want it on your left hand side? And it's really up to you. Usually I just prefer it to be on the left hand side, but it doesn't matter. So here I just decide that I am going to subtract. So I'm going to subtract 6y on both sides. So I'm subtracting the same amount on both sides. So it cancels the equation out. So then 2 minus 6 is going to give me a negative 4. And here, since they're opposites, they cancel each other out. And I have a positive 3. So now I can subtract 1 from both sides. So you have a negative 4y. And it's equal to 3 minus 1 is equal to a positive 2. Since I ran out of room, I'm just going to rewrite it over here. So negative 4y is equal to 2. So now I'm going to divide by negative 4 on both sides. So I can get that my y is equal to 2 divided by a negative 4. So y is going to be equal to a negative 1/2. So notice that here the negative sign is in the denominator, and then I wrote it here in the numerator. I want to make sure that you guys know to keep your notes handy, that if I have a negative 1/2, it's the same as a negative 1/2, which is the same as a 1 over negative 2. So notice how each one represents the same thing, negative 1/2, negative 1/2, negative 1/2. But the negative sign is in different places. It doesn't matter if it's in the numerator or right at the division sign or in the denominator. It still just means the negative value of 1/2 or 0.5, right? So it doesn't matter if I have it top, the side, or the bottom. Okay, I just want to make sure that you guys kept that handy there. So now for number 7, I am going to distribute a negative 4 because my goal is to solve for p. Well, actually, I have the grouping symbols, so I have brackets and I have parentheses. So from here, from order operations, since the grouping symbols is the same thing, the parentheses and the brackets p for the parentheses, then I'm going to work from inner to outer. So I'm going to rewrite this, and I'm going to have a negative 4 p, and the inside of it, I'm going to grab that negative 3 and distribute on the inside. So now I'm going to have a negative 3p, and a negative times a negative is a positive, so positive 15, and it's equal to, and distribute, so I'm going to have a 6 minus a 10p. Now I'm going to grab that negative 4, or actually before I do that, what I noticed is that I have a p here and a p here. So I can combine that before I distribute that negative 4. I'm going to go ahead and do that so I have less terms. So negative 4, and p minus 3p, you can think of it as a 1p, so 1 minus 3 is going to be a negative 2p plus 15. And everything else just gets copied down below. So now when I distribute that negative 4, I have one less thing that I have to multiply by. So now I have negative 4 times negative 2, which is a positive 8p. And I'm going to have 4 times my 15, which is a 60. And it's negative because it was negative 4. And I have 6 minus 10p. So now from here, what I'm going to do is I'm going to add 10p to both sides. So that 18p minus 60 is equal to 6. So if I add 60 to both sides, I'm going to have 18p is equal to 66. And I'm running out of room, but I think I can still fit it. I'm going to divide by 18 on both sides. So 66 divided by 18 is going to give me a fraction. And I know that some of you guys tense up whenever you see the fractions, and just know that you guys are allowed a calculator for this class. So if you have that free app, the one that I told you to do, if you put this into your calculator, and I don't want to get fancy with the fractions quite yet, I just want to make sure that you know if you do not have a graphing calculator, that you can do this on a non-graphing calculator. So if I do 66 divided by 18, it's going to give me a decimal value. Now depending on your calculator, so if you're on this one, for example, if you go to math and then press enter, so it's on the fraction, now it tells you, or it's asking you, you want to go take that answer and turn it into a fraction. So you're going to go press enter, and that's going to tell you that answer that you just computed and turn it into a fraction. And that's going to be 11 over 3. So that that fraction is now going to be 11 over 3, which is the same as that decimal that we just got. So then this is going to be my final answer for number 7. Okay? So we don't have to freak out about fractions. We are allowed our calculators when you guys get these problems. So for number 8, so here I'm starting off with a fraction, versus in number 7, I just ended up with a fraction. So again, we are going to try to get the x isolated. So if I see that divide by 3, then I'm going to multiply by 3 to get it alone. So now I have 3 times my negative 9, that's going to be negative 27, and I have a negative 41 plus x, because I had the denominator and the numerator cancel each other out. So now to get this x by itself, I have a negative 41, so that opposite would be a positive 41. So when I add these together, a positive 41 minus 27, I get a positive 14. So I get that x is equal to a positive 14 as my final answer. Okay. So we are not afraid of fractions. We welcome them, right? It only took me like 3 lines to get there. So x is equal to 14 is going to be my answer. So now for number 9, what I have is I have a fraction in the very beginning. So I'm just going to make sure that I distribute that correctly, and I can definitely use my calculator to do that. So I'm taking this negative 1/9, and I'm multiplying it inside the parentheses. So if I have my calculator, I can say it's a negative 9 halves, and I am multiplying it by the coefficient, which is 8. So that gives me a negative 36. And I have that r. So now my next computation, I'm going to take that negative 9 halves and I am going to multiply that now by 14. So I'm going to get a negative 63. So now I can combine like terms, so I have a negative 63 plus 10, so a negative 36r, and I have a negative 63 plus 10, which is going to give me a negative 53, is equal to a negative 45. Add 53 to both sides, so that negative 36r is equal to, and now you can calculate negative 145 plus 53 to give you a negative 92. Now you want to divide, so divide by negative 36. So I have a negative 92 divided by a negative 36, and that's going to give me a fraction of 23 over 9. Okay. All right. So the next topic that we're going to talk about is conditional equations, contradictions, and identities. So these are going to be the 3 different types. So the conditional, that tells you that it's going to be true for just a certain value for a particular variable. So specific, okay? It's going to be very specific. So it's going to have, like x is equal to 4, for example. Now an identity, that means that there's going to be an infinite many amount of solutions. So even though that the 2 sides may appear different, it really is the same on both sides. 2x plus x is 3x. They end up being equal. And now if we have inconsistent, that means it's going to be no solution. So what's happening with this example is that obviously negative 15 cannot be the exact same value of 20. Those 2 values cannot be equal, right? You can be in debt $15 but still have $20, right? Or on you, right? Right now, at this moment in time, I can have negative $15 and $20 at the same time, okay? Physically in my hand, right? That doesn't happen. That means something is not true there. So here, for the first example, it says determine if an equation is a contradiction, an identity, or a conditional equation. So here, we are trying to decide which value it's going to be. Is it going to be one that gives you a contradiction, a solution, infinite and many solutions, or one exact solution? So let's go ahead and figure this out. So we are going to distribute that 2. So that 2x minus 4 minus 1 is equal to negative 2x plus 7. So I'm going to go ahead and combine this negative 4 and this negative 1. So that 2x minus 5 is equal to a negative 2x plus 7. So at this point, remember, your goal is to see if you get a contradiction, an identity, or conditional. So you're still trying to get that x isolated. So I'm going to go ahead and I'm going to add 5 to both sides. So now 2x is equal to a negative 2x, and I have a 7 plus 5, which is going to be 12. And now, if I were to add 2x to both sides, I would get 4x is equal to a positive 12. And I sort of run out of room, so I'm just going to recopy it over here. So that 4x is equal to 12. So now, dividing by 4, I'm going to get that x is equal to a positive 3. So since I got an actual answer, I got an equation back, then I know that this is going to be a conditional equation. Okay, so I have conditional. All right, so we're going to ask ourselves the same thing. Is it a contradiction, an identity, or a conditional equation with the examples below? So I'm going to go ahead and compute this down here. So negative 4 plus 6x I'm going to take that negative 2 and I'm going to distribute that on the inside of the parentheses. So a negative times a negative is a positive. So it's a positive 2x minus 6. I'm going to distribute that at 3 to get a positive 3x minus 12. So now I'm going to combine like terms. So I have a negative 4 and a negative 6. That's negative 10. And I also have 6x plus 2x, which is going to give me 8x. And over here I have 5x plus 3x, which is 8x, minus 12. So then here what I can do is I'm going to add 12 to both sides. So then I would get a positive 2 plus 8x is equal to an 8x. So if you see it here, you can stop. Some students are just like, what? See what? Well, if you keep going, hopefully you can see it, the solution already. But how can both sides have an 8x and an 8x and be equal when this has an additional 2 value? So we really have 2 plus 8x is the same as 8x, but both sides already have 8x. So what's happening is, well, if I were to subtract 8x from both sides, then I would have that 2 is equal to a 0x. But 0 times anything is 0. So you're saying that 2 is the same as 0? Does that make sense? So you want to stop and reflect about this. Can the two different values be exactly the same? Are they identical? No. So what this happens is that now you have to categorize this. So it's definitely not like you got a value, you got a contradiction, there's no solution. So whenever there's no solution, you say contradiction. Okay. So now for part 3, again, I'm isolating the variable, so I'm going to solve for y. So I have a 15y plus 32 is equal to, and I'm going to distribute this 2 inside the parentheses. So 20y minus 14 minus 5y plus 46. So now 15y plus 32 is equal to, and for my y values, 20 minus 5 is going to be a 15y. So now negative 14 and a positive 46. Is going to be a positive 32. So now you can see that I have really a 15y plus 32 is equal to a 15y plus 32. Do you see how both sides are equal to each other? They're identical, right? They both have a 15y and they both have a 32. So this is a 15y, there's a 15y, here's a 32, and there's a 32. And of course you have that equal sign right in between them. So these values are exactly the same on both sides. So you can stop and realize that both sides are identical. And because they are identical, then you're going to say it's an infinite amount of solutions. And let me just make sure it is a identity. You want to make sure you say identity. You always want to make sure you go back and actually answer the question, right? So they wanted to ask us at the very beginning whether or not this was a contradiction, an identity, or conditional equation. So because this was what it was asking us, we want to make sure that we answer it. So that's why I went back and saw that we have to answer this as identity. Okay, well, that is the end of chapter 1.1. So if you guys have any questions, please feel free to email me. Thank you.